In the last section, we saw how the camera puts everything it sees into middle gray. So, what happens to the subject when it doesn't? For the answer to that, let's take a look at the center section of the original zone scale. Here we can see zones 2 through 8. The original scale had a few more zones on the top and bottom, representing the ability of printing paper to distinguish subtle differences between the very bright whites and the very dark blacks. For the digital photographer, however, we're only concerned with zones 3 through 7. These are the zones that will render detail in our subjects. Anything that is brighter or darker will be left as pure black with no detail or pure white with no detail. This is the origination of the term latitude. Latitude is the film's ability to render detail over a wide range of brightness values. Here you can see that our digital cameras have 5 stops of latitude. This is similar to the latitude achieved with slide film, but as camera makers keep improving our sensors, we can expect the latitude to expand. Here we can see how the zone scale relates to the exposure display within our camera. It shows us that one stop equals one zone. In this example, by setting your camera at 1/125th at f8, you have zeroed out the meter. The subject in front of your meter will be rendered as an average value. But if you open up from 1/125th to 1/60th, your subject will be rendered one stop brighter. Closing down from 1/125th to 1/250th will darken your subject down by one stop. Now at this point you may be thinking, hey, my camera's display doesn't look like the one on the screen. Well, different models have different displays, but they all do the same thing. For starters, some cameras won't show you this display unless you're in either manual mode or aperture or shutter priority. In some of the program modes, it might just show you a plus or a minus, or perhaps even nothing at all. So, take the plunge and put your camera into manual mode and follow along. In this example, our camera is displaying half-stop increments. So, moving your shutter aperture dial one click will make a half-stop change. Moving your shutter aperture dial 2 clicks will make a full stop change. Here our camera is set to 1/3 stop increments. You can see there's a couple of extra hash marks in between the full stops. Moving your shutter aperture dial 1 click only makes a 1/3 stop change in this case. You have to move your shutter aperture dial 3 clicks to make a full stop change. So let's say that we set our camera to 1/125th at f8. This zeroes out our camera. We can see the hash mark at the 0 point on the scale. Our subject is rendered as an average reflectance. If we opened up our camera to 1/60th, our hash mark moves to let us know that the subject in front of our meter will now be one stop brighter than middle gray. Opening up 2 stops to 1/30th moves our hash mark up to the +2 mark, rendering our subject bright white, but still retaining detail. Going all the way up to +3 renders our subject pure white with no detail at all. You wouldn't want a large or important subject to fall in the +3. It's simply overexposed, completely blank. It's nearly impossible to bring back detail from a subject that has been this overexposed. Going in the other direction simply darkens our subject down. Closing down to 1/250th renders our subject one stop darker than middle gray. Closing down to 1/500th renders our subject black with detail. And closing down 3 stops places our hash mark at -3, which lets us know that the subject in front of our meter will be pure black with no detail at all. You can, however, pull a little detail out of this zone if you're working with digital imaging software, but we'll cover more on that later in the video. As mentioned earlier, not all camera displays look the same. Some of them are placed on the bottom rather than the sides. And most will not have the plus and minus numbers. So here's a much closer match to what you'd be seeing inside your camera. But even here the display could differ from what you see. Some cameras' positive side is on the left, as seen here, while others may have the positive side on the right. So be sure to check your manual or look for the plus and minus marks to ensure that you're placing your tones correctly. The other difference may fall with the total amount of hash marks that are displayed. Here you can see the display is showing us a 3-stop range on either side of 0. Many cameras will only show a 2-stop range. This is completely normal. Okay, so let's see what happens to actual subjects when we place them in the different zones. Here we have a shot of a black train. When my hash mark is set to 0, my train is overexposed. Remember, this is a very dark black train, and yet my camera has made it much too bright. When I close down 1/2 stop, the train will be rendered darker. Closing down can be done by making your shutter faster, such as moving from 1/30th to 1/60th, or by making your aperture smaller, such as f8 to f11. Now, just a note here, you'll not see this change happen in your viewfinder as you're seeing it here. This is just for demonstration purposes. This darkening will only occur to the image after you make the exposure. Alright, so closing down a full stop places the part of the train in front of my spot meter at zone 4, or -1. Another half stop down moves it into the black zone. And finally, when you have closed down to -2, you have placed the tone where it belongs, black with detail. If you close down another half stop, your hash mark will begin to blink. This is the camera's way of telling you that the subject is going to be underexposed. It's falling outside the display. In this case, it's falling into the -3.5 spot. Notice how we have lost detail within the circle? It's gone pure black. Closing down another half stop to -3 just continues to darken down the entire scene, and your hash mark continues to blink. The same thing would happen in reverse with a brighter subject. Here the camera is looking at the white wall and is thinking, this is very bright. I have to give an exposure that's going to make it an average reflectance. So when you place your hash mark on the 0, it gives you a middle gray wall. Open up a half stop, and it begins to get a little bit brighter. +1 looks a little bit better. And a +1.5 is the most accurate look for this scene, I think. However, even if we open it up to +2, we still retain detail, and now the wall is bright white. Opening up any more, and the hash mark starts to blink, letting us know we're facing overexposure. So, through the previous examples, we can see how any tone can be brightened or darkened. Let's take a look at what happens to actual colors when they're lightened. Our average tones turn into pastels. Think spring colors. Easter. +2 should be reserved for tones that are really, really bright. Think snow or bright sand. As the colors get darker, think of dark blue jeans or pine trees. And -2 should be reserved for really, really dark objects like black Labrador retrievers, coal, or even black trains. This is a good chart for giving you an overall feeling of where colors should be placed on the zone scale. Take some time to study it and become familiar with it. In the next section, we will continue with our color recognition and placement on the zone scale.